Welcome, mathematicians. Today we're going to become mathematical lumberjacks. We're going to be dealing with logs and exponential equations. So let's begin. First off, we have to sharpen the old axe. We have to start learning the rules of logs and logarithms. Otherwise, we're going to be completely lost when we cover these. So I want you to memorize all of the logarithm laws. Okay, the exponential laws are good to know, but the logarithm laws are absolutely essential to this lesson, all right? Next thing, we're going to cover what is the log graph. What does it visually look like, all right, before we really start to dissect the problems. All right, so I have here in green the log graph, and in this case it's base 2, but if you look at base 10 or base whatever, it's going to have the basic shape of that green line, okay, no matter what base. And the same goes for the red line. It's going to have the same basic shape no matter what base that it is. So let's start covering, well, what is the domain and the range of these functions? So starting with the exponential graph, the domain is from negative infinity to positive infinity. It's all real numbers. And the range is everything greater than 0, because you notice you can never have 0 as your y value. No matter what value of x you pick, you can never have a 0. Now, the log graph is the same thing, just the other way around now. So the domain this time is everything except, or I'm sorry, everything greater than 0, because you can't ever have 0. And the range is all real numbers, because it goes all the way from the bottom to the top of your graph. So you see, the exponential graph and the log graph are inverses of each other, and this is going to be very helpful to us as we start to dissect the problems. Alright, so let's start out with solving logs without a calculator. Alright, so these are some common problems that we might come across. So I have log base 10, and that's what it is when it's not written in there. Log base 10 of 100. Okay, now the way we do that is we set it equal to x. Okay, that's our first arrow there. So we set the equation equal to x. Alright, now let's acknowledge though that it's log base 10, okay, when it's not written in there. So that's our next step, where I have log base 10 of 100 equals x. Now remember how I said exponential equations are inverses to log equations? Well, this is the application of that. So if the base is 10, we can actually raise it, well, we can make a base of 10 and raise that whole log 10 of 100 to that power. So what we have now is 10 to the log 10 of 100, and I know that looks complicated, but really all that's going to happen is the log base 10 and the 10 are going to cancel out. And then you take the x and you make that the exponent base 10. So then basically the question you ask yourself is 10 to what power gives you 100? And hence we get our final arrow, which is 2. Okay, 10 to the second power gives you 100. Alright, here's another one. So let's start out on the very left. We have log 5 of 125. Just follow the same process that we did earlier. So we're going to set it equal to x, first step. Now here's an alternate way to think about it. You could think of it as 5 times what gives you 5 to the power of what gives you 125. Or you could take 125 and you can break it down into its prime factors. So if you take 125 and break it down into its prime factors, you get 5 to the third power equals 5 to the x power. So then it's clear to see then, if you cancel both bases out, that your answer is x equals 3. Right, now here's another one. This one comes up quite a bit too with fractions. They do it to throw you off. So let's look at log base 1/2 of 16. Okay, so log base 1/2 of 16 equals x. That's our first step. Now, as before, we're going to raise everything to the 1/2 power. So I've done that, leaving us with just 16. And then on the right, we have 1/2 raised up to the x power. So I'm going to follow the previous method that I did, where I broke 16 down into its prime factors to get 2 to the 4th power. So 2 to the 4th power equals 1/2 raised to the x power. Now this requires you to know those exponential rules that we covered on the first slide. So how can you get 1/2 to flip around to make it 2? So you have to use a negative exponent. That way it flips the fraction around, and then you just make it the desired number that you're looking for, which is 4 in this case. So your answer comes out to be x equals -4. All right, and then the last one. This one's really easy. Log base 3 of 3 is 1, and that's one of the log rules as well. But just, simply a log 3 with a base of 3 is just going to cancel out. All right, now, how do you solve logs with a calculator? Okay, now, let's say you don't have a fancy calculator, or, a calculator that doesn't have the ability to change bases, okay? What you need to know is the change of base formula. And so just carefully looking at this, it basically is going to, I'll just sum it up for you. It says if you have an equation like this where you have log base 3 of 6, you can actually separate it into 2 logs and say that you have log 6 divided by log 3, and you get 1.63. Now it doesn't have to be just regular log, it could be natural log as well. So look, if we have log base 2 of 12, then we can actually separate it into the natural log of 12 over the natural log of 2 is 3.58. This way, you don't have to worry about bases on your calculator. Now, if you do have a calculator that does bases, then by all means just put it in the normal way that you would. So let's get on to some good stuff. All right, let's get on to some questions. 4 different questions, and these are some of the hard ones, and there's maybe one about average, but these come up a lot on tests, these types of questions. So it's very, very important for you to get familiar with these types of problem setups, okay? So we're going to tackle them right now. Take a look at them, by the way. Pause it, try and work them out, and I'm going to do the solutions right now. Alright, so here's problem 1. 16 to the n minus 7 power plus 5 equals 24. Alright, well our first step is going to be to subtract 5 from both sides, okay? When we do that, we get 16 to the n minus 7th power equals 19. Now how in the world are we going to get that exponent off? Well, this comes from the log rules that you have to memorize in the beginning. Take the log of both equations, both sides of the equation. This way that exponent n minus 7 can come to the front of the problem. That way we get n minus 7 times log 16 equals log 19. And then at this point we're going to divide by log 16 on both sides. That way the log 16s cancel out, leaving us with n minus 7 equals log 19 over log 16. And now at this point we just finish it off by adding 7. Plugging this into your calculator, you're going to get a value of about 8.06. If you got that, awesome job. You did it right. All right, now let's move on to problem 2. Okay, this one's a lot smaller than it seems. Okay, so we have the same bases, right, on these logs. So you just raise them to, or you make them with a base of 3. I know it's hard to say that and put that into words, but you're making them both a base of 3. That way the logs cancel out, leaving you with 4 minus x equals x plus 8, and just solve it like you normally would, and you get x equals -2. Let me add a little disclaimer here. Don't forget to test for extraneous solutions, okay? So when you get a number, put it back into the original, to the argument of the log, so into the original value of x, and see if you get either 0 or a negative number. If you do, then you know that you had an extraneous solution, at least when you put it into a log equation. Alright, now let's move on to part 3. So this one's a little bit bigger, okay, but you have to know the log rules, okay? So this type of thing is just basically going to follow those rules. So addition is the same thing as multiplication of the arguments of the log. So let me show you what I mean. That means that instead of saying log x plus 2 plus log x plus 1, you can combine it to say log base 2 of x plus 2 times x plus 1, and then do the same thing on the other side of the equation. Now, as in problem 2, you notice how they have the same bases? We can just get rid of them, all right? And oh, by the way, sorry, you simplify this, so you FOIL those, okay, and distribute the other one. Now, like I was saying, the same bases and the same logs on both sides are going to cancel out, leaving us with just x squared plus 3x plus 2 equals x squared plus 4x. Now, just simplify that, and you get x equals 2. All right, and don't forget to plug it back in, but obviously it's going to work because everything is addition. All right, now problem 4. Now this one's a real tricky one, all right? But again, it all is just based upon your knowledge of the log rules. Okay, so we know if addition is multiplication, then subtraction is division. Okay, so that's our starting point. We're going to divide x by the square root of x minus 1. Now, it's log base 2, right? So let's cancel out that log by making everything a base of 2. That way we get the log canceled out, okay, and then 2 squared, which is 4, by the way. So now we have x over the root of x minus 1. So what we're going to do is we're going to multiply by that denominator. That way we can cancel it out, giving us x by itself. Hence, I have x equals 4 parentheses square root x minus 1. Now at this point, we're going to distribute the 4, okay? So we get x equals 4 root x minus 4. Now, what you want to do is set this equal to 0. And that's tricky because you might look at it and be completely lost. But it's one of those things that comes up every once in a while. It's a u substitution. And you know that, like I said, that's very rare. It does come up, but what you have to do is let u equal that middle value, the square root of x, and therefore u squared equals x, so that you can substitute those x values for u's, giving you this equation, which is much easier to work with. Now, what are the factors of 4 that add up to negative 4? Well, it has to be x minus 2 and u minus 2 and u minus 2. So solving that, you find that u equals 2. So u, we said, was the square root of x. So the square root of x equals 2. Now the way you cancel a square root is by squaring it. So square the x, square the 2, and you get x equals 4. All right, you've made it to the end. Awesome job, people. I'm so proud of you guys. Seriously, that was a lot of information. Now, if you have any more questions about what we just did, feel free to message me. If you want to see more videos, more questions, please submit your ideas to me. Just send me an email, and I'll look at it, and I'll try and get it up as soon as I can. But anyway, thank you for watching. Don't forget to subscribe and like, and just leave some feedback. See you next time.